Our next tool is regressions, and this is where we use a tool to help us predict results. So we would love to predict the future, but while not perfect, regressions give us formulas that help find relationships between the variables we've identified. Some are independent, which are the basis on which we can have predictive value for the dependent. We'll do an example so these terms hopefully make more sense. There are several types of regressions. The first one is a linear, which simply takes two variables and looks at the relationship between those two. And the second is multiple, where we have two or more variables that help explain or estimate the value of the dependent variable. Again, let's look at examples. A lot easier with examples. Let's take an example where there's two variables, x and y, and data points for those. So first we say, wow, that's pretty scrambled. Let's start with a graph. I always believe that it's good to visualize the data before you start tearing into numbers, just to allow our brain a sense to get the reasonableness of the results that we're going to get. So let's go into Excel and do a graphic. Here's the same data we saw for x and y. And if it's laid out in this fashion of x then y, then we can simply shade it and insert graph. And here we just do a scatter plot where we have x and y graphed against each other. So this is a scatter plot. You can also see it in all charts and just select scatter, but you end up in the same place. So this is a graph. And visually we see, oh, there is a pattern. They're not all over the place. There's actually a pattern that the higher we go along the x dimension, the higher we go along the y dimension. So there's a positive relationship, and we could actually imagine a line going through it. Okay, so the first observation is that there is a relationship. So by graphing x versus y, we see that there's a relationship because generally see that there is a upward sloping relationship. The more of x, the more of y. But we can do better than that because Excel does this for us as well. We can use the linear regression function inside Excel to get far more precision than simply looking at a chart and fitting by eye a line through those points. So to do the regression, we use the analysis tool pack. So it's here in data and then data analysis. And then we'll go down to see regression right there. Okay. We have to be very careful to select the right variable to put it in the right cells. So here, input the y range, hit the up arrow, and the y is here. Y means the dependent variable. And then next we say, what is the x range? Shade the x, which is the independent variable. Then we click label here because we captured the top row, which are the labels, and then we say OK. These are the regression results. Looks like a lot of numbers, which it is, but I'll just highlight the most important numbers. These two numbers are the parameters that will define our formula. So obviously those are very important. Next is the adjusted R squared. We won't go into heavy statistics discussion right now, but I'll give you things to look for in regression to tell you if the fit is any good or not. The adjusted R squared speaks to how good is the line that came out of the regression fitting with the data. One way to think about it is that if every single data point is on the line, then that is 1.0. It's 100%. Stated another way, it's what percent of the variation is explained by the formula. And if every single dot is on that line, that means 100% of the variation is captured by the line. Anything less than that is less than perfection. Here, 83% is pretty good for a regression. All right, next we're going to look at a couple of items, significance F and the p-values. These should be below 0.05. We see that the variable of x is below 0.05 because that's to the negative 6 power, so we're way out in the significant digits. And then F is also negative 6 in the significant digits as well. So this is a pretty good fit. And we say, okay, how would we use it? We can now derive the formula that comes out of this regression. I'll put it right here since it's right above us. So y equals, And we start with the intercept. So the intercept is 12.86889. And then we look at the next term, which is x, and it's a positive sign, plus 0.464017 times x. And that's the formula. Represents an estimate that if you knew x and you put it in this formula, you can estimate what y would be, right? So that's the main purpose of the regression. You can see it's not that complex. Why? We let Excel do the heavy lifting for us using the function found in data analysis called regression. So we have something that looks like this. If we had a scatter plot, the line would look like that. Here's the formula that we just derived. And here are the regression statistics here, right? So that's pretty good. Well, what if we want to use a different method, the multiple regression?